Okay, so here's sort of a interesting experiment. What we have here is a sine wave oscillator producing about 13 hertz, and the output from the oscillator goes up to this big power amplifier here, and that thing is putting out a clean sine wave at about 30 volts RMS. All of this is driving this crazy woofer, which is really quite the monster. And it's moving back and forth, hard to say, but somewhere near an inch, or 25.4 millimeters if you wish. And I'm monitoring the current on this device, which is a clamp-on current meter. And the output of that is actually going to the scope, and you see that waveform there that's quite distorted. It's 100 millivolts per amp, so this is very close to 1 amp RMS that's going into this speaker. So what that means is 30 volts, 1 amp. The impedance of this thing at this frequency is actually 30, which seems odd, but it's fairly close to the, wow, that's wrong too. The thing isn't walking back and forth right there. It's that's just an artifact of the way this camera takes a picture. But anyway, in the back you can see a nice Tektronix laboratory power supply, all kinds of other meters, and including a sound pressure level meter. But this thing isn't making any sound because it's a dipole. You've got positive pressure on the top of it, and you got negative pressure, on the bottom. So it just cancels. That's why we have to put these things in a box. Anyway, as I zoom out, you can see current probes, meters, and my old TEF, which still works, all sorts of other interesting equipment, and a rock on a piece of copper. So that's the end of this video. I hope you found it instructive, and if you didn't, that's fine too. It's kind of a complicated thing. But in the end, impedance is nothing other than volts over amps. Remember that, and you have a nice day. Bye.